Here we show an important transition practice between eliciting students' ideas and supporting ongoing changes in thinking. In this video, we show how a whole class of high school students can debrief their initial models with the help of the teacher. By debriefing, we mean to make students' thinking public. But simply making it public is not enough to help students take advantage of the ideas of their peers. The role of the teacher, then, is to point out differences in the models that may help some groups of students pick up on the ideas of others, or that help them see alternative ways their ideas could be represented. This is done in a non-evaluative way. I asked one of my novice teachers to facilitate this process as one might in a K-12 classroom.
Last time we met in class, where we drew up our initial models, what we thought was kind of how the organisms were interacting in the ecosystem. Since they're kind of small, why don't you guys all stand up and come up to the front? Also, something that I noticed is how you guys decided to organize these. If we look, for instance, at this model right here, and if we took away all the sheets of paper, we would kind of see this like upward trend, so it's kind of all flowing up. Where some of the other ones over here kind of flow more into almost a circle or more of a web. So different ways that you guys decided that they were connected or interconnected. There's some differences, as well as the things that we asked you to write. How were they connected? Some people chose not to do that. Some people talked about how that they're feeding under the sea ice, and so that's how it's connected. But this poster over here, I thought, did a really interesting job of kind of some causes and effects, like if one population drops off, then another population is going to increase or decrease, so there's kind of some balances in there, some back and forths they represented. I thought you guys did a really great job, but the neat thing about this is that we're going to continue to work on our models. And that's exactly what scientists do in the real world. So scientists come up with an idea of what they think something looks like, and then they go, how are we going to find out if what we think is true? So they go and they do research, or they go and look at the penguin populations and see how they affect each other. They collect evidence, and then they come back to their model and say, well, now that we know all this stuff, how can we change it to reflect what we really saw happening in the world? So that's what we're going to do. We're going to take the time to learn about ideas and learn new information and think about it and figure it out, and then we'll come back and we'll rearrange what these look like so it's a better reflection of what is happening in the ecosystem.
That's nice job, Tina.
Oh, don't go anywhere. No. Let's debrief what Tina did, because this is the stuff that you have to do. So, what did Tina do that made you notice something, or how is this a good way to start a class? What did she make you pay attention to?
She compared how different groups interpreted the task of making this initial model, I guess, and pointed out things that were different about them and things that, I guess, that were important or that were worth noting about them.
General trends.
And I like how she talked about how the arrows are all pointing up. And that kind of is a prelude for talking about trophy pebbles later on.
She said that scientists continually work on models, or we'll continue to work on this, and today we're going to add more information so we can not necessarily make them better, but make them more accurate as far as the Antarctic ecosystem goes.
So she did make any value judgments on their initial models as well.
How do you do that, Marie?
It wasn't like she said this model did the best job of representing so and so. It's like this model is showing this.
Yeah.
Just stating facts about the models instead of saying this is good, this is bad.
Yeah, she didn't seem to ignore any of them, really. Like, she didn't, just walk to that one and, ignore the rest of it.
But we should also think about what puzzles do we have? Are there gaps in our knowledge that we know about, where maybe you should tell me about those, and maybe in a couple days, maybe I should design a lesson that targets these gaps. So I want you to think for about 15 seconds right now without talking to anybody, and just look at your poster, because you know that poster best. What do I need to know more about to make a change here? There are different ways to say what I said.
Are you worried they won't stand there for 15 minutes quiet?
15 seconds.
Oh, no, 15 minutes.
I'm not gonna stand.
All you need, the first time you do this, all you need is for one student to give you a reasonable remark, and what other students are hearing then is an example of what counts as a gap. So we'll try it. So does anybody know that they have a gap in their thinking about their poster, that if they just knew a little bit more about X, they could revise their poster? Kimmy?
So this is my poster. I was thinking like, what all other things does killer whales eat that also eats like the penguin? So that it can help me putting more things in the food web.
You think that there might be some organisms missing.
Yeah.
Maybe I, as a teacher, gave you a simplified set of organisms and there's more to it than this.
Yeah.
Okay. Graham?
Our poster we have sea ice, and I know that sea ice is largely seasonal, and I don't know if any of those other organisms vary in population size for over seasons.
Yeah.
So I'd be interested in knowing that.
Yeah.
So you think that some of these relationships are change over time depending on what season it is?
I think it might.
Or the strength of the relationship might change?
Yeah.
So you would like to have us have a conversation about fall, winter, spring, summer, and what the sea ice looks like?
Yeah, we were really solid that there was some relationship between phytoplankton and sea ice. And I know sea ice is seasonal.
Okay. So those are two good examples of contributions, gaps that we think we have, and I can easily take either one of these and maybe the day, not tomorrow, because I can't plan that fast, but maybe the day after tomorrow, I can take up the climate idea, climate plus seasonal changes, and then I can also add some more organisms in the system in another few days. That's easy for me to do. And then at least two students feel like the teacher's paying attention to their ideas. And then the students get used to looking at their models or their own ideas with a critical eye to what is it that I might be missing. Okay, good job. All right, let's